Welcome to Modeling and Analysis Lab. In this video, we'll discuss simulation of plate with the circular hole when subjected to axial load. This is the second problem on plate with the circular hole. A rectangular plate with the circular hole is subjected to in-plane traction as shown in figure. We have to consider Young's modulus of elasticity, that is E equal to 200 GPa and Poisson's ratio 0.3. We need to find out maximum stress when it is subjected to axial load, and we have to find out deformation of plate. So this is a plate with the circular hole and having diameter 50 and whatever the cross section, that is 200 here, and width is 100 millimeter, and it is subjected to in-plane traction, that is 20 megapascal, and thickness of the plate is 10 millimeter. In the simulations, there will be always three important steps. One is pre-processing, second one is processing, and last one is post-processing. So before that, we need to start with the pre-processing setting. So that is we have to go for file, preference, geometry / model, solid geometry scale factor. So we have to give convenient units, whether it may be millimeters, meter or inches, and you have to give OK. So next step, you have to reset whatever the dialog position. So that is with the help of same option, that is file, preference, user interface, reset, dialog position, OK. So how to give initial setting? So that is with the help of this option. Go to file. So in that last option we have, that is preference. So in that option, first option, that is geometry model. So for that we need to go for this option, that is solid geometry scale factor. So it is the factor you can see here, that is different units. So you have to maintain one unit, that is system of unit. So I'm going to prefer here millimeters, so that's why I'm going to select this one. So after that I'll give OK. So next we have to go for again file option. So that is under this preference we have to go to this option, that is user interface. In that reset dialog position, and give OK. So this is the pre-processing initial setting. Once you get this window, now next step we have to create a plate, and in that you have to make a hole. So for that we have to follow this option, that is go to geometry. In that surface, because we are going to create here surface, because it is a plate, two-dimensional. For that purpose we have to go surface. If it is 3D means you have to go for three-dimensional. So hence it is surface. You have to go to this option. By corner method you are going to create plate. So that is with the help of you have to go this corner. You have to create ID. First you have to create ID 1, that is x coordinate as 0, y coordinate as 0, and z coordinate as 0. Click OK. Next ID 2, you have to create x as 200, y as 0, and z as 0. OK. Next you have to go to ID 3. So that is x 200, y 100, z 0. OK. And go to last coordinate, that is x 0, y 100, and z 0. OK. So you'll get a rectangular plate. So for this plate we have to create now circle of diameter 50. So that we have to create now. To make a hole in the plate, so you have to go to again geometry option. So in that you have to go for curve, circle, in that we have to create circle by center option. So we have to locate whatever the hole at the appropriate location, so that is with the help of coordinate. X we have to give as 100 and Y we have to give as 50. At the middle of the plate we have to make a hole, and Z is 0, so you have to give OK, and you have to give the radius. So diameter is 50 millimeters, so that radius will be 25 millimeters, so you have to give OK. Next you have to give cancel. Whatever the geometry of circle we created, so that we have to remove from the plate, so that whatever the hole it will create. So for that you have to give, again you have to go to same option, that is geometry. In that mid surface you have to go. So in that we have to go with the trim with curve. So you have to trim that whatever the circle. So you have to select this plate, then you have to give OK. So next you have to select you have to trim this one, so that's why you have to select this hole. Now you have to give again OK. So now you have to give cancel. So that is the step to trim this hole. Now you have to delete whatever the geometry from the surface, that is you have to select this circle and you have to delete. So how to delete? For that again you have to go to this option, that is delete option. So go to delete, then again go to geometry, you have to go to surface and you have to select this circle, then OK you have to give. So again it will ask to delete the surface, again you give OK. So whatever the circle, so that will be deleted. So now we will get a plate with central hole. So now we have to go to next step, so that is we have to apply material. So for that one you have to again go to model. So in that so material, so you can give the name for material, that is steel material, and you have to assign property, that is E value, that is 2 E5. Then Poisson ratio can give as 0.33. So next you have to give OK, because only one material, so you have to give OK. So there is no second material, so ID2 is not required, so that's why give cancel. You have to create material property. For that one again you have to go to same option, that is model. In that property of plate you have to select, so that is why you have to create ID1, because only one property you have to assign for the material. So title you can give as plate, then material whatever the assigned material, so that you have to assign to this plate, that is steel material, we have already assigned that one. Now whatever the thickness, so before that you have to check whether it's a plate type of element, because it's 2-dimensional, so you have to go with the plate element. So it's already selected, give OK. Then go to thickness, and the thickness of the plate you have to assign, so it's given in the problem, that is 10 millimeter, and give OK. So ID2 is not required, because only one plate here, so that's why you cancel this one. Now you have to mesh this whatever the geometry, so that is with the help of this option, that is go to mesh. In that mesh control, so you have to select whatever the surface, that is size on the surface, you have to select entire surface. So go to this option, that is select all, so then click OK. So this entire surface will select. Now we can choose any number of element size. So I am going to select now 8 number of whatever the size, that will I'll select 8. So then I'll click OK, cancel. So this is the, now we are assigning the whatever the size of the mesh. Now we have to go to again mesh geometry, you have to go to surface. Now again you have to select all. Now you have to assign appropriate element, which type of element you have to assign. So So this is the standard element you can select, that is quad. Before that you have to check, because you already given the property for the plate, so that it is assigned or not, you have to check properly, because in some cases there will be a more number of property, so you have to select appropriate one from this dialog position. So now whatever the element you can see here, that is try quad, so I am going to use now quad element. Now I will give OK. So this is the mesh going to create. So next step is we have to apply a constraint to this plate, that is one side should be fixed and then other side you have to apply whatever the load. So for that purpose again I will go to this option, that is model. In that constraint, so on curve, because entire curve we have to, so go to constraint, then on curve. Now we have to give whatever the condition, that is title as fixed one. So I am going to fix left side of the left side, that is left side curve. So that's why I will give OK. Now I am going to select this curve, so that is left side. So I will click here, so it will indicate. Now I will give OK. So fixed, it will ask again, I will give fixed. Now I am going to cancel. So all the left side will be fixed. Now after that I have to apply load on right side of this plate. So again I have to go to model, in that load option, on curve I am going to give load. So that is I will write here title as load. Now I will select right edge of this plate, so this will highlighted like this. Next I will click OK, and I will give force, because whatever the stress they have given in the problem, so I am going to convert into load. So that's why whatever the load that will be acted at the right side of the plate. For that reason, so I will untick this one, and I am going to give only in X direction, so that is positive side, 20,000 I am going to give. Then click OK, then cancel. It will ask for a next ID, so next ID is not required for us, so I will give OK, cancel. Now I am going to analyze this problem, because it's a structural problem. So I am going to again model, analysis. So I am going to new option, new analysis. I will give a plate with the hole analysis. So the analysis program will be Nastran, and analysis type is structural. So I am going to select this one, static. So there are many options you have. Next I will give next. So now I am going to analyze this simulation. So it will ask for any error, so it will loading now, it's in processing. So now you have to check whether any error is there or not. So for that one I have to click here, load the result. So it will show some of the error, warning message, information. If any if it is the error is not there, it indicates that the problem is correct. So now go to continue. So next step is post processing. So you have to visualize all the stresses and deformation. So for that reason, so you can see on my stress plot by clicking this option, that is contour plot. So also you can press by F5, so you can see here. So there will be a draw model and go to deform, then contour. So in that you have to select deform and contour data. So for that reason you have go with these two options, deform and contour data. So for that one you have to search here on mices stresses. Next you give OK. So okay, so you can see this plot. So it is both including deformed. So you go to undeformed form. So this is the maximum stress near the hole. So that is 79.93 Newton per millimeter square. So now you have to find out again in the similar way. You have to find out deformed view. For that reason again you have to go to F5. So in that deformed shape contour, then deformed and contour data. So you have to select now total deformation is nothing but total translation. That is first one you have to select. Now click OK. So go to deformed shape and deform one. So whatever the total translation, so that indicates here that is 0.028 millimeter. So this is the